This is our project in which we've built a protocol that uses the best of Uniswap v3 concepts like concentrated liquidity and tick calculation and the efficiency of curve finance to generate a superior AMM protocol that enables you to trade multiple stablecoins in a single AMM pool. It's basically a spherical AMM pool in which you can trade any number of stablecoins to it gets you lower gas fees, and it also gives better returns to the liquidity providers. So let's go through the demo. So here we have a basic swap interface, and it's basically spherical innovation which uses spherical geometry and n-dimensional space concept to calculate and apply concentrated liquidity. And let's go through the maths. It uses concepts like reserve vectors, k constant, trade calculation, and many other heavy computational maths to finally give us the output amount, the best output amount for calculating the best trades. So we also use vector mathematics and tick classification generation of k constant values. And let's go to the liquidity interface. So in this liquidity interface, we'll add liquidity, and this is our analytics dashboard in which you can analyze multiple stable coins behavior to generate trade plans and get better results for our trades. And you can visualize the different we have deployed 5 stable coins. You can visualize how they are being done, and we can see the graphs. So let's go to the liquidity feature. Let's add some liquidity. So we're adding 1,000 coins for each. So this is confirm, and we can see this on our explorer that if we refresh, so just 6 seconds ago we got this transaction, and so this is our transaction, and on the this is the contract address, and you can see have the transaction was executed. So let's go to the swap now. We'll be swapping USDC to USDT. You can choose any of those coins, and we can see the earliest balance was 10,000, and now it's 9,000. So let's swap 20 stable coins. So let's execute the swap, sign the transaction, and yeah, the swap is successful. So let's see this transaction on Arbitrum, and yes, we can see that we were able to swap 19.15 stable coins. That is a pretty good amount for the amount of liquidity we have provided, and we're getting very good return rates, basically 95% efficiency. So let's see how exactly is this possible. So we have 2 contracts, the solidity contract and the stylus contract. The stylus contract handles all of the computation, the mathematics part for generating the output value. So we use the solidity contract for the state management and Rust contract for the computation because it offers lower gas fees and better computation and better efficiency. So we can see that we're calling the solve torus invariant, which is being handled by the orbital helper.rs. So let's see how all of this math is actually working. So this is our look at the swap function. In swap function, we can calculate the output. It calls this underscore calculate output function, which goes to the stylus contract, and it calculates functions like calculate radius, solve torus invariant, calculate boundary ticks. So using all of these parameters, we generate the final output value, which is being sent to the solidity contract. So that's how it's done. So for visualization, I would recommend that you imagine one tick as a spherical AMM. So combination of all of these ticks gives us a generalized torus invariant, which you can see through this first demonstration. So it's basically, in simple words, it's a spherical AMM that is the future of AMM, using very less liquidity, getting very good returns, and handling all of this computation in single. And It's based on paper by Paradigm, Orbital Paradigm, which does all of this research on it, and we've implemented this. Thank you for your time.